Hello everyone. This video is in continuation of Lambda expressions in Java, where we learned in detail about functional interfaces and the properties which makes an interface a functional interface, along with different syntactic flavors of Lambda expressions. I highly recommend you to watch that video before jumping onto this one. Now in this video, we will talk about different functional interfaces introduced in Java 8 as part of the SDK itself. So let's jump onto it. A quick recap before we start. A functional interface is an interface that has exactly one abstract method but can have a lot of static and default methods along with any methods from the object class. Now you might have already seen runnable since version 1 and comparator since version 5, and there are many of these in different packages until Java 7. But since Java 8, with the introduction of Lambda expressions, a host of functional interfaces have been created and are put inside the package java.util.function, categorized as Predicate, Supplier, Consumer, and Function. Let's get a higher level understanding to what these categories are. Supplier. This takes no input and just supplies or returns back an object. The method name of the functional interface is get. Consumer. This takes or consumes an object and returns nothing. The method name of the functional interface is accept. Next, predicate. This tests something on the given input and returns just a boolean to signal success or failure. The method name here is test. And finally, function. This takes an object as an input and applies something on it to return another object. The method name of the functional interface is apply. You should try and correlate the interface name with the method name. So a supplier supplies an object, a consumer accepts an object, a predicate performs a test on an object while returning a success or failure, and a function applies something to an object to return another object. Let's now talk about the supplier in more detail. So the interface of the supplier looks like this. It represents a supplier of results, and there is no requirement that a new or distinct result be returned each time the supplier is invoked. Now if you notice the interface, the supplier uses generic T in its definition, but then there exist a couple of more suppliers which have more concrete types. So as you can see here, we have boolean, int, double, and long suppliers whose return types are as per their interface name. Also, the method names for the corresponding interfaces are prefixed with get, which is our supplier method name, appended by the method flavors. Let's now look at a demo. Let's create a supplier which generates a random number between 0 to 100 exclusive. And let's print it using the get method of the supplier. And we can see a random number being printed here. Let's look at another example. Let's generate a continuous stream of random integers in a range from 0 to 9. Now generate function expects a supplier for the stream. So let's fill it up. And let's limit the stream to only 5 numbers and print each of them. And you can see the 5 numbers being printed here. Let's now talk about predicate in more detail. So the interface of a predicate looks like this. It tests and asserts something about the past argument. And then we have BiPredicates, with the difference that it performs tests on 2 objects rather than 1. So similar to suppliers, there exist a couple of more predicates which have more concrete types. We have int, double, and long predicate whose input types are as per their interface name. Also, the method name is test for all of them. Now in addition to the test method, predicate contains a couple of more default and static methods. Let's go through them one by one. So negate, end, and or method acts as chain methods to other predicates, and you can create many combinations from these. Is equal returns a predicate that tests if two arguments are equal as per object's equals method. Let's now look at a demo. Let's understand our setup first. So I have the class student score, which contains a student's name, his or her previous score, and new score obtained. I have created a static utility here which populates a dummy list of students with their score data. And let's now talk about our goal. So the goal is to find out all the students who have been consistent performers with the following conditions. The new score obtained is more than 5, and second, the new score obtained is greater than or equal to the previous score. Now to achieve this, let's create two tests or predicates, one for condition 1 and one for condition 2. So let's write the predicate for condition 1, which is minimum score criteria. Let's test it. So it fails for 2 as it is less than 5 and succeeds for 6. Let's now write predicates for the second condition. And just to demonstrate the chained methods, let's create two BiPredicates, one for greater than and other one for equal to condition. So our better new score criteria would be or of the two predicates. Let's test and see the results. So you can see that it has printed true as 10 is greater than or equal to 8 and 10 and false for the last case. Let's now jump on to the goal of this exercise. So let's iterate over the student and score list and filter them out using the predicates which we had written and collect them in a list. So we have filtered all the students with the minimum score criteria. And finally collect it in a list. Let's now print the list. So the minimum score criteria is met by Alice, Bob, Dave, and Eve. But then Eve doesn't satisfy the second criteria of better new score criteria, which is this. So the result is Alice, Bob, and Dave. Let's now talk about consumer in more detail. So the consumer interface looks like this. It represents an operation that consumes or accepts a single input argument and returns no result. And then we have BiConsumers, with the difference that it takes two inputs to consume rather than one. And similar to Supplier and Predicate, there are a couple of more consumers which have concrete types. So we have int, double, and long consumers, whose input types are as per their interface name. And we have similar interfaces for BiConsumer as well. Note that the method name is except for all of them. Now in addition to except method, there is another default method and then in consumer. So the way it works is, first the consumer on which and then has been called is invoked via except method, which is then followed by the after consumer of the same type. So chaining this gives you a composed consumer. Let's now look at a demo. So we have the same student score class from our previous demo and a list of dummy data in my test class. So from our list of student scores, let's do the following. Print name of each student in as is, lowercase and uppercase form, and then print name and current score for each of the students. So let's solve our first case, and for that let's write three printers. Let's now create a composed consumer, chaining them one by one. So first we will use as is printer, followed by lowercase printer, followed by uppercase printer. So we would be using consumers and then method. Let's now print all of the student names from the list in all forms. And you can see all the names in all three forms. Let's now move on to our second use case, which is to print name and the current score for each student. So let's write the name score printer BiConsumer. And again, let's print it for all of the students. Now it expects two arguments, one string and the other integer. So we'll use students' name and their scores here. And you can see the student score list here. Let's now talk about function in more detail. So the function interface looks like this. It represents an operation that accepts an argument and produces a result. And then there is a specialized function called Unary operator, which takes and returns the same type of object. And as you might have already expected, there is a BiFunction which takes two inputs and produces a result R. And then there is a specialized BiFunction called binary operator, similar to Unary operator, which works on a single type and takes two inputs and returns the same type of object. Now there are many functional interfaces similar to functions involving int, double and long as either an input or output, with the other part being any other generic object t and r. And then there are functions with different permutations to int, double and long input and output. Also, the name of the method for these are apply while they are intuitive in other cases. And like functions, there are interfaces involving int, double and long for BiFunctions as well. And there are interfaces involving int, double and long for unary and binary operator too. Now in addition to apply method, there are other default methods compose and end then, along with the static method identity. Compose applies a function before the function to which it has been changed. So if our function takes t as input and outputs r, the argument to compose takes v and gives away t, which works fine as our function input. Similarly, and then works after our function object is invoked and its output acts as an input to after function. The identity function is very simple. It simply returns as is to whatever is supplied to it. Let's now look at a demo. I have the same setup of student score with some extension. I have overridden hash code and equal method which says two objects are same if their name matches. In my test class, I have a method that populates dummy student score data. So we have two scores for Alice, one for Bob and one for Charlie. Let's now understand our goal of this exercise. So number one, take the average of previous and new score for each student. Number two, calculate the percentage from them. So we have to assume a max score of 10. So all these scores have a maximum value of 10. Now once the percentage has been calculated, we need to format the percentage to two decimal places suffixed by a percentage sign. Next, we have to create a map of student and the percentage, which we obtained in the previous step. And in case of multiple percentage for the same student, for example, in case of Alice, the value of map should be comma separated. So the expected output is Bob with some percentage, Charlie with some percentage, but for Alice we will have 2% because there are two entries here. So let's create a chain of functions, one to take the average, followed by one to calculate the percentage, followed by one to format the string, where we would append the percent sign. So let's create these functions. So we are dividing it here by 10 because that is the maximum score. Now let's chain all of these. So we would use the and then method from our function interface. So first of all, average function, followed by percent function, followed by number to string function. Let's test it with two test cases, one with two fives, and let's run a similar test case with 5 and 10. So in our first case, average would be 5 here and the percentage should be 50%. And for our second case, average would be 7.5 here and the percentage would be 75%. Let's run the code. And the output is as expected. Let's now jump on to the map creation. So let's stream the student score list. Now this expects three arguments. One, a function to generate key for the map. The second one to generate the value. The third argument is a merge function. Now we want our key to be student score itself, so we can use function interfaces identity function, which takes and returns the same input and output. For the value, it will be our overall percent function, which takes input the student's previous and new score. And finally, the merge function. Now what happens when we already have the percentage entry for Alice and another entry of Alice comes? Well, in that case, merger function is used to resolve collisions between the values associated with the same key, and in fact, merge function is a binary operator. So in this case, it would take two formatted percentage strings and would return another string. And as per our rule, let's separate them by a comma. And let's now print the map. And you can see our map here, and you can see how the value for ls is separated by commas. A quick recap. So we know that Java had some functional interfaces already present before Java 7, but with introduction of Lambda expression in Java 8, Java provides a host of functional interfaces inside the package java.util.function. We looked at Supplier, then at Predicate and its variant BiPredicate, Consumer and BiConsumer, and a host of variants for function including BiFunction, Unary operator, and binary operator. We also looked at different versions of int, long, and double interfaces for all these categories. Well, that's all folks around the built-in functional interfaces. Hopefully things are organized and are in better shape for you now.